All right, welcome Algebra 1 students. Thank you for coming to this video lesson of Unit 6, Topic 15. If you have your books, that's great. If you don't, that's all right, no big deal. You can just grab a scratch of paper and pencil and do a couple activities with us and you'll be all right. All right. Today we are going to find out about vertex form. All right. The warm-up, it says, what do you notice and what do you wonder? So usually we do this in groups and you're thinking about, what do I see? And you're getting to hear like what your neighbor thinks. But since you don't have a neighbor thinking and telling you what they see, I'm going to tell you what's going on in my head. And then we can do a notice and wonder together. So I'm going to give you a second. Look at these sets. We've got set 1 and set 2. All right. Think about, what do you see there? What do you maybe wonder about? Well, all right, I know it's been a while since we've been doing some math, so let's refresh our memory. We've got some vocab that we've worked on. So this is in what form? Remember the names of those forms? Yeah, some of you said that. Very good. Standard form. That's in standard form. Okay, and what is this form? You're right, it's in factored form. You guys remember all of this. That's awesome. So factored form, we can tell it's factored because we see those parentheses, right? We know, this says multiple factors being multiplied together. Here we don't see any parentheses. Now this third form we haven't seen yet. Today's lesson is called vertex form, so it's possible that that's what that is. Oh, I wonder if that's vertex form. But why are they in a set? Like, all three of these, are they the same? X squared plus 4. Oh, if I multiply x times x, I get x squared. If x times 4. All right. Okay, distributive property gives me that. Now, I'm not sure exactly. Well, I do know because I'm a math teacher, but I'm pretending I'm your group mate. I'm not sure. Does that equal those? It doesn't. I have to work on that a little. All right. Now these, what I notice here, there's some weird things going on. There's a negative x squared here, which none of those have. Here we have a negative 1 out in front, and then here it's weird. It's like x minus 1 here, and then 5 minus x. So it's kind of like backwards. Instead of saying x minus 5, it's 5 minus x. So if I multiply this negative x times x, I get negative x squared. Okay, so we've got negatives going on over here. All right, so those are some things we noticed. Maybe we're wondering, what is this? This is factored form, this is standard form. All right. So we are gonna look at a whole new form. So first we're gonna discuss it, and then we'll identify this new form and how it can be helpful, and we will talk about some observations. All right, so here are the two sets of equations for quadratic functions you saw earlier. In each set, the expressions that define the outputs are equivalent. So now they're telling us they are equivalent. Okay, so all three of these are the same but look different, right? Like 10 is the same as 5 times 2, right? Is the same as 4 plus 6, right? So they're just 3 different ways of writing the same amount. All right, so the expression that defines h is written in vertex form. So let's see, whoa. I'm gonna go back a second. Okay, so h is written in vertex form. So we had standard form here, f is standard, g is factored form, and h now, this one is called vertex form. We're gonna explore that today. All right, it's saying we can show that it's equivalent or equal to the expression defining f by expanding that expression. So it looks like they're gonna do the work for us. They're gonna show us, okay, let's see. What did they do? X plus 2 squared. What did they do? They took x plus 2 and wrote it out 2 times. That's a great idea, because when I have something that's squared, it's that same thing times itself, minus 4. Now, there are a couple different ways to expand that out. Some of you use the box method, and some of you use distributive property. I know that some teachers have told you the word FOIL, but we want to kind of get away from that because FOIL, first, outer, inner, last, really only applies to a binomial times a binomial and nothing else. So you may be needing to do a binomial times a trinomial, so 2 times 3. So distributive property always works and the box method always works. It's just a way of organizing your information. FOIL is just kind of limited. All right, so they distribute that. X times x is x squared. X times 2 is 2x. 2 times x is 2x, and 2 times 2 is 4. And then they combine that 4, negative 4, that cancels out to 0. These become, all right, and then we get back. So that was our last one, and came back to our standard form. So we just went from vertex form to standard form by multiplying that all out. Cool. All right, so vertex form of a quadratic expression looks like this. A vertex form of quadratic expression in x is a times x minus h squared plus k, where a, h, and k are constant, and a is not 0. Because if a was 0, 0 times anything is 0, so it would just be a constant. Wouldn't be much going on with that x squared. It wouldn't be quadratic. All right, so now it's asking us to show that the expressions defining r and p are equivalent. Okay, so the first and the last, right? So standard form and vertex form. So we have to go from vertex form back to standard form. Ooh, okay, so what I want you to do is I want you to hit pause on this video, and I want you to get some scratch paper and a pencil and try it, work it out. I'm going to go and share a whiteboard so that we can check it out together, but I really want you to try it on your own as well. Okay, I'm going to write this out. So we had -1 times x minus 3 squared plus 4. And we want to show that that is equivalent to, I need to go back. Let me unshare. Stop share. Oh, that's not what I meant to do. Sorry. Oh, hey, I can pause my recording. All right, I'm figuring all this stuff out. Okay, let's see, I can move this toolbar. Okay, so we need to find that this -x squared plus 6x minus 5, we need to show that that is equivalent. So this is my standard form over here is equivalent to my vertex form right here. Okay, so if you haven't paused and tried this on your own, take a minute, pause, try it, and then see how you do. All right? Okay, so if you're not wanting to try and you're feeling like you need some support, I am here for you. Okay, so one thing that's going to happen here, we've got this -1 and we've got this quantity x minus 3 squared. So we want to be really careful to write that out, x minus 3 2 times. Okay, now multiplication comes before addition, so we're going to multiply these quantities together, right? Okay, so when I have 3 things being multiplied together, when I say 3 things, I say the -1, the x minus 3, and the x minus 3 are 3 quantities being multiplied together. And sometimes students want to do this. If I say a times b times c, sometimes students say, oh, I want to multiply a times b and a times c. We need to be careful because that is true if we were doing something like that, right? Distributive property, a times b, a times c, if it's a sum of 2 different terms. But if it's just a times b times c, then really what we need to do is multiply a times b, and whatever that result is, we're going to multiply that times c, right? So let's try like 2 times 3 times 4, right? So I'm going to go 2 times 3 is 6 times 4. Now I could have done that in a different order, but I only multiply each one in one time. Okay, so I just wanted to clarify how that works. All right, let me get rid of this so it's not distracting us. Okay, so All right, so I'm going to multiply that negative in. So a negative x and a positive 3 is now what I have when I combine those two together. Okay, and I still have this x minus 3. So I'm going to use the box method. I'm going to come over here. I'm going to draw my box. I've got, oh, come back. I've got x and minus 3. I guess I'm too close to the edge here. It doesn't like it. Minus, all right, sorry. I will draw it on this side. X minus 3, adapt and overcome, right? Okay, and then over here, negative x plus 3. Okay, so I put the first one on top and the second one, I put it kind of here on the side. Okay, all right, so then I'm going to multiply x times x, negative x squared, and you're probably already done with this. So if you want to fast forward through this, that's great. Plus ends up being plus 3x and then minus 9. All right, now I see two terms that are alike, so I'm going to combine these terms because they're both linear x, they're just one x. So I end up with negative x squared plus 6x minus 9. All right, so let's move that back up here. I don't want to forget about this plus 4, it's still there, right? Okay, so these two combined together gave me that, what's in blue, negative x squared plus 6x minus 9, and I still need this plus 4. So I can put those two together and get negative 5. All right, negative x squared plus 6x minus 5. So that looks, oh, check it out, negative x squared. All right, we are good. They are equivalent. So this is our vertex form, right? Vertex form. And we haven't really explored why it's called vertex form yet. We will in just a minute. It's really cool. All right, and then over here it's standard. Sorry, my pen isn't writing well. Standard. Whew. Okay, you got the gist. All right, great. I'm gonna stop that and put back this one. Okay, great. So it's saying here are the graphs represented by the quadratic functions. Why do you think expressions such as those defining h and r are said to be written in vertex form? So this is why do we have the name vertex form? Okay, so this is h in vertex form. Here's the graph of h, and here's r in vertex form. I do not want to tell you, well, eventually I have to tell you. I mean, I don't have to, but we need to talk about it. Okay, but I really, really, really want you to think about it. Okay, we got some important points here, right? -4, 0, 0, -2, -4. Those are all super important, right? X-intercepts and the, what's that called? The lowest point or the highest point, the max or the min, that is the, oh, it's called the vertex. Okay, and then this is +1 and 5. I don't see a, well, I see a 1 there, but 1 and 5 are important. And then I see 3, 4. 3, 4 is important. Oh, that's the vertex. And this is called vertex form. That's the vertex, and that's called vertex form. 3, 4. Something's not right, though. This says -3, and that's a +3. This says +4, that's +4. Okay, over here, let's see, whoa. Here's the vertex, -2, but that says +2 and -4. Oh, do you see the relationship? All right. Okay, so let's have a student show that the expression defining R and P are equivalent. R and P are equivalent. Well, So we already did that. I'm sorry. I'm like, what are we supposed to do here? We went through the math of that. All right. But the vertex is here. So remember, in standard form, what we notice is we see this. This is our intercept. It's our y-intercept. With factored form, we see our intercepts. +1 is an intercept, right? Opposite of that. And then here, 5 minus what makes 0? 5 minus 5 makes 0. So 5 and 1 are both intercepts. And here it's showing us our vertex, but it's +3, 4. All right, interesting. So we've got our y-intercept, our x-intercepts, and our vertex. So each of those forms gives us something special. All right, what information does a quadratic expression vertex form reveal? The vertex, of course. How does it show that information? It gives us to it in the form we call it h and k. What doesn't it tell us? It doesn't tell us the y-intercept. It doesn't tell us the zeros or the x-intercepts. Why is this form used? Well, it's nice to find the center. Sorry, the sun is really bright all of a sudden. It's nice to find the center. The vertex, right, that has symmetry on either side. That's a nice place to start. All right, give us a situation where it might be useful. In modeling, well, oh my gosh, we talked about so many different things, right? We talked about like maximizing revenue, right? If we charge too little or too much for something, people aren't going to buy it as much. But if we charge just the right amount, right, we're going to maximize that our profit, right? So revenue could be maximized, and that vertex is the maximum. All right. Playing with parameters. All right, so here we're going to get to play in Desmos a little. So it's asking you to do 1, 2, 3 things, I think, here. So first it's asking us to go and put a value next to x inside the parentheses and see what happens. Okay, so I'm going to do it here. If you want to go to Desmos or on your TI calculator, you can do that. So I'm going to, what am I going to do? Just exit full screen and go to Desmos. Okay, so I started with y equals x squared. How I got this squared, I went to this little keyboard down there if you haven't done that before. Okay, so I already put y equals x squared just so we can get a general picture of like what the parent function looks like. Okay, y equals, I'm going to put parentheses now, x, let's see, it suggested we did like +3. That might not be the exact one. All right, why isn't it parabola? What did I forget? Oh, my x squared. Okay, so I have to hit that squared button. This is so weird. Do you agree this is a little weird? It says x minus 3, but we went, look where our vertex is. It's at -3, 0. And my explanation for this is what value do you have to plug back in here to make that get back to the red one? Well, we have to subtract 3 to make that equal 0. So subtracting 3 from that right there, so we do the opposite. So like what would make that 0? -3. All right, cool. All right, so how would I make it go to the right instead of the left? Exactly. All right, I'm going to try to copy this. Not use my pen. But instead of +3, I would like to try x. X minus 4, not 43. Ooh, just 4. Okay, all right, and then we move 4 to the right. Interesting, right? So x minus 4 here becomes x plus 4 here. That's super important. You are going to see this again in Algebra 2 and pre-calc and calculus and all of that wonderful stuff, and later on in this course. Okay, so that was the first thing they wanted us to explore, and then they wanted us to explore what if we put a number afterwards. Okay, so I'm going to take this and I'm going to say +3, or let's say +2. What's going to happen if I put +2? Is it going to go down 2? Oh, it went up 2. All right, okay, so in the inside, that's the opposite, but here it really just went up 2. All right, I could go -5, and it went down 5, but we can't see it very well because we zoomed in. Okay, all right. So when it's on the outside of the squared, we're believing it is exactly what it looks like. All right, cool. The other thing they wanted us to explore was what happens if I put a number out in front? Like if I put a 2 there, did my vertex change? Here, I'll take it away. Put a 4. Did my vertex change? I'll put a 7. vertex is still the same, right? Do you see it? So I'm comparing the purple and the black, and that vertex for the purple and the black, they both have that same vertex, -3, -5. So putting a dilation out here really didn't affect that vertex at all. What happens if I put like a negative number? Did that affect my vertex? Do you see it right here? Let's put this down. So it reflected, right? Instead of opening up, now it's opening down. But what if I did -2? It's just steeper and flip. But vertex didn't change. So vertex form, we've got that H and that K. That A really doesn't change my my vertex at all. It just makes the shape of the parabola different. Very cool. All right. So we were supposed to explore all those things. We did a little bit of exploration. So this is the good part. This is where you get to try and practice and see how much you've learned. All right, so without graphing, so don't sneak and use a Desmos or your graphing calculator. You want to predict. It's okay if you make a mistake. That's when you learn something. It's actually good to make mistakes sometimes. I mean, you're sitting there by yourself, right? Okay, so maybe somebody's sitting next to you, but it's cool. Make a mistake, learn from it. All right. You're going to predict the coordinates of the vertex. Okay, so if you have your book, you can find this in your book. If you don't, just jot down on a piece of paper. Okay, you're trying to find what are the coordinates of the vertex, and then does it open up or down? All right, so take a minute. I'm not going to spend too much time because I don't want the video to be so much longer. So I'd like you to hit pause, try that, and then hit play, and we'll talk about it. All right, I'm assuming you've already tried this. If you haven't tried it, hit pause. Okay, so coordinates of the vertex. Notice there's no K. This is our H value, and there's no K value. So the K value is going to be 0. So here our vertex is going to be -10, 0. All right, and it opens up. How did I know it opens up? Because it's a positive value out in front. Yep, good. All right, here vertex is +4, +8, opens up. Here, +4, +8, but opens down. Here, what? There's no movement, H. There's no right or left movement. There's only a down 7. So 0, -7 is my vertex, and it's opening up because it's positive out in front. Here we've got -3, right? Opposite. -3, -5 is our vertex. Up or down? Did the 1/2 change up or down? We just need to look, is it positive or negative, right? So positive, so it's opening up. -100, -50, opens down. Whoa, okay. -M, positive N. Did I say that right? Did I say -100, +50? I hope I did. I hope I didn't misspeak. Sorry if I did. Okay, -M, positive N, right? The opposite of M, exactly what I see for N. And then how do I know if it opens up or down? That actually has 2 parts to it, right? If A is a positive number or bigger than 0, it's going to open up. And if A is a negative number or less than 0, then it's going to open down. All right. This just asks us to talk about it. Oh, now it's saying use graphing technology to check and see if you're correct. Oh, why did I just tell you all the answers? Okay, if you want to go back and check them, you can plug those in and practice working on your window and zooming in and out. All right, cool. This is a neat one. This has a dilation. If you want to try this, take a minute. It's a good challenge where, you know, try to write the equation of this so you know the vertex, but then you have to make sure all these points match up. When you first do it, it doesn't match up, so you have to figure out the right A value to make that work. All right, let's synthesize our lesson. All right, let's discuss the connection between the 3 different forms of quadratic expression. Standard form has a constant term C, right? The vertex form also has a constant term, we call it K, right? We got the K. Are the 2 constant terms visible on the graph in the same way? Okay, I would like us to go back to that problem we did earlier. I'm gonna exit full screen real quick. And let's delete all of these, not all of them. So the problem we did earlier, we said negative x squared. Come on, come back. Okay, negative x squared plus 6x. Oh, here, I'll pause the video real quick. All right, so as you can see, there are actually 3 equations here. One is here in red, one is here in purple, and the other is here kind of in the same color, red. All right, now what I did was I was like, okay, this was standard form of that like problem set earlier, and then we multiplied this one out so we could get that, right? I want to look at the y-intercept. Where does it cross the y-axis? It crosses at -5. That's why we love standard form. Standard form says, hey, look, if I plug in 0 for x, that goes away, and I just get -5. So 0, -5 is a point on my graph. So I can see the y-intercept is super easy. Now, if I look at this value, that looks like a constant too, but 4, I do not cross here at 4. My question is why? Why is that not the y-intercept 2? The reason why it's not is, remember when we multiplied that out, we got x squared plus 6x minus 9. So we had that constant plus the 4. So we had to combine those two, that -9, that +4 together to get that -5. So we have to be careful. Standard form, that's when we can find our y-intercept super easy, but vertex form, kind of the hint, like the name, vertex form, gives us our vertex super easy, but it doesn't show us the y-intercept there. Okay. All right, let's go back. I think we are almost done. All right, in both the vertex and standard form, the squared term has a coefficient, which could be 1. Does this coefficient affect the graph in similar ways? That is something to consider, isn't it? So if I had a number like, let's try it. So we know these two are the exact same graph, right? What happens, let's say if I want to put a 2 here. If I say it's 2 times, whoa, do you see where that moved? That moved in a completely different spot. What's going to happen here? Is it going to move? Is my vertex going to change? We already explored that. The vertex doesn't change in vertex form. But here, when I plug the 2 in, see, without the 2, the vertex stayed the same, but if I plug a 2 in, whoa, totally different graph. So I would say that that a value does not do the same thing. We could explore that some more, but if we have a coefficient in front of x squared, that's different than that a value. All right, now cool down. Your teacher might assign this as a activity, but let's see. This was our goal for today. I can recognize the vertex form of a quadratic equation. Yay! I do want to make a note about that. I can relate the numbers in the vertex form of a quadratic equation to its graph. So the h and the k, opposite h and k. All right. Okay, so that was that. So I am just going to go back to whiteboard really quickly. And let's get a new fresh page. Okay, so I just want to share, right? Oh, let me get my pen back. So sometimes we're going to see stuff like this, x squared plus 4. That is technically in standard form, but it's also in vertex form, right? Now, vertex form, we're more used to something like that for vertex form because we're like, that's my h, that's my k, right? But technically, that's still considered vertex form, okay? All right, so you don't have to have those parentheses there, all right? But if we see any linear term like 3x, then it's definitely not in vertex form. Also, if I see 2 sets of parentheses only, then that's in factor form, not in vertex form. All right, thank you so much for watching. I hope you learned something. Welcome back to school.